Okay, this is a limit question. The limit at which x tends to 0 of x integral exponential minus t dt from 0 to x over square root of 1 minus exponential minus x squared. Now this integral problem here, that's the integral of exponential minus t from 0 to t dt. Now if we are to integrate this function, let u be minus t. That implies the u is equal to minus the t. The u is equal to minus the t, and the t is equal to what? Minus the u. Now this becomes the integral exponential u dt. Now the t is what? Minus the u. Minus the u. Now to integrate exponential u with respect to u, that's what? Exponential u. That's minus exponential u. Now the boundary is from 0 to x. The boundary is from 0 to x. 0 to x. And remember that u is taken as what? Minus t. That's minus t from 0 to x. And that's minus exponential minus x minus exponential minus 0, which is exponential 0. So that becomes minus exponential minus x. Exponential 0 is 1, and there is negative outside, that's plus 1. That gives 1 minus exponential minus x. Now, the limit of the function can be written as x, then the integral of this is 1 minus exponential minus x, 1 minus exponential minus x, over the square root of 1 minus exponential minus x squared. Now, direct substitution, x tends to 0. If you input x here as 0, that's 0, 1 minus exponential 0 over 1 minus exponential 0. That's 0 over 1 minus 1 is 0. Square root of 0 is what? Is 0. So 0 over 0 is what? Indeterminate. 0 over 0 is indeterminate. Now we can rewrite the limit of the function as 1 minus exponential minus x over, we can bring this x to the denominator. And this denominator here is what? Is having a square root. So this can be written as the root of 1 minus exponential minus x squared. This is x, taking it down to the square root over x squared. Because the square root of x squared is what? Is x. Now, this is a rational function. This is a rational function. This is a rational function. So, and direct substitution gives what? Indeterminate. 0 over 0. So we can apply L'Hospital rule. You can apply L'Hospital rule. Now apply L'Hospital rule to this function here, and apply L'Hospital rule to this function here. Now f of x is 1 minus exponential minus x, and g of x is 1 minus exponential minus x squared all over x squared. Now, all is by what? 1 over 2. Square root 1 over 2. So, by L'Hospital, the limit of the function x tends to 0, f of x over g of x is limit x tends to 0, f prime of x all over g prime of x. Now this is f of x. F of x is 1 minus exponential minus x. So if f of x is 1 minus exponential minus x, that implies that f prime of x, the derivative coefficient of f of x, is 0. That's plus exponential minus x, which is exponential minus x. And this is g of x, which is 1 minus exponential minus x squared over x squared. if you want to apply L'Hopital to this one, the limit of this function, you can take the limit of this function, then raise to power 1 over 2. You see the same thing. So if you want to apply L'Hopital to this, apply L'Hopital to this function and hold on to what? To the square root. Just apply L'Hopital to this g of x, which is 1 minus exponential minus x squared. So if you apply L'Hopital to this one, that's g 1 minus exponential minus x squared over x squared. Now g prime of x, your result will be square root of, differentiate 1, that's 0, differentiate it, that's plus 2 x exponential minus x squared over x squared, that's 2x. So that gives 2x cancel 2x, that's exponential minus x squared. So the limit becomes x tends to 0, f prime of x is what? Exponential minus x over square root of g prime of x is exponential minus x squared. So input the value of x as 0, that's exponential 0 over exponential 0, that's 1. That implies that the limit t value of this function is equal to 1.